In our previous lesson, we learned to multiply sets that contained binomial terms. We also apply the basic rule of multiplication of sets. In this lesson, we want to learn to rationalize sets with monomial and binomial denominators. By the end of the lesson, you will be able to 1. Write the conjugate of a given set. 2. Rationalize set with monomial denominator. And 3. Rationalize set with binomial denominator. Let's look at conjugate set. The idea of conjugate set is extremely simple. Given root A plus root B its conjugate is root A minus root B. What do you notice? Root A plus root B has just become root A minus root B. Isn't that simple? For root A minus root B, can you write the conjugate set for this? That's correct. You have root A plus root B. Very simple. Now let me test you. Write the conjugate set for the following. 1. 2 plus root 3. Root 3 minus 1. And 2 root 3 plus 3 root 5. This becomes 2 minus root 3. Great. This becomes root 3 plus 1. And this becomes 2 root 3 minus 3 root 5. Good job. Now let us see what happens if we multiply a set by its conjugate. For example, for the set 5 plus root 3, its conjugate will be, have you written yours? 5 minus root 3. Beautiful. Now let us apply the concept we learned to expand this. This is going to be (25 minus 5 root 3 plus 5 root 3 minus root 3 squared). And that becomes, watch, minus 5 root 3 plus 5 root 3, like sets. And that goes off because minus 5 plus 5 is 0. So we have 25 minus the square root of 3. You remember? That gives us 3. And this becomes 21. Okay, that'll be 22. Very simple. What do we realize? We realize that if we find the product of a surd and its conjugate, we get a rational number. Let's look at how to rationalize a surd with monomial denominator. Let's look at this particular example. If you have a surd, for example, a over root b, 1, our interest is on the denominator. To rationalize this surd simply means that manipulate it so that the denominator, which is an irrational number, becomes a rational number. 2, in the denominator, we have only one term, and that is root b. Therefore, that is monomial, one term. Let us try and rationalize this. To rationalize a over root b is very simple. Multiply the numerator by the root b as well as the denominator by the root b. This becomes a times root b over root b times root b. This simplifies to become outside, so that is a root b over root b squared. That becomes a root b over b. Initially, it was root b, an irrational number. Finally, we have b, a rational number. We say that we have rationalized the denominator of the surd a over root b. Let's take a typical example. We want to rationalize 3 over root 5. It's very simple. Our focus is on the denominator. It's a surd, root 5. So we're going to multiply the numerator and the denominator by root 5. That's what we get. We simplify to have 3 root 5 over root 5 squared. And finally, we get 3 root 5 over 5. Remember again, initially, the denominator was root 5, a surd, irrational number. Finally, it has become 5, a rational number. Example 2. We have 5 over 2 root 3. It becomes now we get 10 root 3 over 12. But you see, this part of the surd is rational. This is also rational. And they have a common factor, and that is 2. So we can reduce that. Two divides this one, 5. Divides this one, 6. We have 5 root 3 over 6. That was quite easy. Next, we look at when the denominator is a binomial? Let's look at a surd with a binomial denominator. We have a over b plus root c. This is a binomial, 2 terms. So to rationalize the denominator, 1, you need to identify the conjugate of the denominator. Then 2, you multiply the denominator and the numerator by the conjugate. Very simple. So in this particular case, our surd in the denominator is b plus root c. Therefore, its conjugate will be b minus root c. Let us multiply both the numerator and the denominator by b minus root c. Then we can go on and multiply. So numerator multiplies numerator, denominator multiplies denominator. Do not divide this or divide this by this. So we have a times b minus root c over b minus plus root c times b minus root c. We expand the numerator using distributive property, where a multiplies b and then a multiplies minus root c. A times b becomes ab. A times minus 1 root c becomes minus a root c. Now, the denominator is quite interesting. You have b plus root c multiplying b minus root c. You realize that the first term here is equal to the first term here. The second term, root c, is the same as root c. The only difference is that in the first bracket you have a plus sign, and here you have a minus sign. This represents an identity in mathematics, and let us quickly review that. Now, a plus b in one bracket multiplied by a minus b in another bracket can be simply written as a, which is the first item here, squared, minus b squared. And we call this the difference of two squares. The difference of two squares. So we can apply that to quickly multiply the denominator. So first, second. It says pick the first one, b, square it, minus pick the second one, root c, square it. That's beautiful. This becomes ab minus a root c divided by b squared is b squared minus root c squared, you remember, becomes c. And you are done. Look, we started with a surd, a binomial containing surd in the denominator. We have ended with just a rational expression in the denominator. Therefore, we have rationalized the irrational expression here. Let us now take a life example. Rationalize and simplify. 1. 3 over 2 root 3. 2 plus root 3. 3 over 2 plus root 3. To rationalize the denominator, 1. Identify that it is a binomial, 2 plus root 3. 2. Form the conjugate of 2 plus root 3. And obviously, it becomes 2 minus root 3. So I am multiplying both the numerator and the denominator by the conjugate of the said 2 plus root 3. 3 multiplies this, and that will be 3 into bracket 2 minus root 3 all over 2 plus root 3, 2 minus root 3. I'm going to expand this one. Now we are here. We have 2 plus root 3, 2 minus root 3. You remember, a plus b, a minus b becomes a squared minus b squared. So our first item is 2. We square it, minus our second item is root 3. We square that. The numerator will remain the same because there are no like sets. The denominator, however, becomes 2 squared minus the square root of 3 becomes 3. And this reduced to 6 minus 3 root 3, 4 minus 1, 3, is 1. And the denominator is 1. We don't normally write it. This brings us to the end of this lesson. I hope you are able to identify and state the conjugate of given sets. You have also learned to rationalize a set with monomial denominator. We went on to also look at how to rationalize a set with a binomial denominator. Remember, to rationalize simply means to make an irrational number or expression a rational number. In our next lesson,